Hello and welcome to my live stream, the last one, in fact, for data. What am I doing? Finance and recursion. Getting ready to do data and statistics next week. I'm going to smash through the data and statistics. If you can just give me a thumbs up or a yes, I can hear you, that would be good. I think everything is set up and working. But if you're out there and watching in YouTube land and can just let me know that you can hear me, that would be greatly appreciated. I'll wait for just a second. No one's coming back saying, can't hear you, mate. So I'll assume that all is going well so far. Right, what I said I would do is actually I would kick off with where I left off in the last video. And that's actually the VCAR questions behind me. There are some interesting questions. And these ones here deal with what I call change of conditions. And so basically, this is where they give you a scenario that effectively changes part way through. So thank you very much, Ty. Greatly appreciated and welcome. Good to see you as always. So these are the trickier questions, and these are the ones that if you looked at the VCAR report, they would turn around and go, oh, these were very badly done. All right. So actually, it's interesting that Cambridge, their new textbooks, have actually given this a little bit more of its own chapter, basically, because I think it's important for those of you out there who want to get the high scores. So here we go. There is a change of conditions. I'm going to bring up my calculator. I'm going to fire up my TI Inspire to go and menu 8.1. And there we go. And obviously you can probably see here that I've already started. So I'm actually going to close that down, clear it off. Nope. And let's go back and start a fresh document. Menu 8.1. Sorry, 8 and then 1. And we're good. Right. So Bob borrows $400,000 to buy an apartment. The interest rate for the loan is 3.14% per annum, compounding monthly. A scheduled monthly repayment that allows Bob to fully pay the loan in 20 years was determined. And believe it or not, this is where the first part of the question actually ended. That's where the first conversation or the first change of conditions wanted you to focus. It goes on to say, well, Bob actually wanted to pay interest-only repayments for the first 2 years. Now, if you've understood anything about interest-only loans, the principal and the final value do not change. All right. So what that basically means is those 2 years worth of payments don't actually change the principal value. Then it goes on to say that after the 2 years, the interest rate changes and Bob's still able to pay the loan off in 20 years. Okay, so we'll deal with that in just a moment. The first thing is I'm going to fill in my financial solver. So my principal value, because it's a loan, is 400,000. So 400, he says, don't do 0. So that's 400, 1, 2, 3. What does it say? It's going to take it out for 20 years. Now, we're initially considering the 20 years situation here. We're turning around saying, well, okay, hold on a moment. Let's pretend he's doing it for the 20 years. So that's going to be 20 times 12. The reason it's 20 times 12 is that it is compounding monthly. What is my interest rate? 3.14%. We're assuming that after the 20 years, it's been paid off. And so therefore, change my PPY and CPY to 12. And what I can do is find out that my payment, if that was to happen, is going to be he says, writing in highlighter, 2246.53. Okay. Now that is the first part of the question. That's the scheduled monthly repayment that allows Bob to repay the loan in 20 years was determined. It then goes on and says, well, Bob, however, decides to make interest-only repayments for 2 years. And that tricked a huge proportion of the state because they're like, okay. But the point of that was that my principal value didn't change. He's just made 2 years of payments. That was the interest only. All right. So does that make anything difference to the PMT? Absolutely not. After these 2 years, the interest rate changes. Right. So he's already made 2 years of payments. So my N now needs to change because he wanted it over 20 years. He's made 2 years of payments. So now that this becomes 18 times 12, he's only got 18 years left. Because again, it says here, after these 2 years of payments, the interest rate changes, which tells me I. Bob was still able to pay off the loan in 20 years. All right, so that means the 18 years left by repaying a scheduled amount each month. That's this scheduled amount here. So what is the interest rate for the final years? Well, again, nothing else changes because my principal value stayed, my final value stays the same. And if I hit enter there, I get 2.21%. Now, obviously, I'm pretty happy there because the chances are that that is going to give me the correct answer, which was B. But did you see what they did there? They tried to trick you. They got something worked out, then they suddenly turn around and they changed the idea to say, oh, it's an interest only. And then they come back and they say, oh, hold on a moment, he now wants to continue for 2 years. Deliberately tricky. and there to actually, yeah, pretty much throw spanners in the works. We move on to a very similar type of question. So once again, I'm going to close this down because I don't want values in my financial server. I'm going to do menu 8.1. And let's see what we come up with. 20 years ago, Hector invested a sum of money in an account earning interest at a rate of 3.2% per annum compounding monthly. After 10 years, he makes a one-off extra payment. And again, VCAR love doing this type of thing, this extra payment to the account. Right, that's after 10 years. So he's doing 10 years, he's then making an extra payment. For the next 10 years, the account earns interest at a rate of 2.8% per annum compounding monthly. The balance of his account today, hold on a moment. So again, the trick to this question is you had to actually work backwards through it. They weren't giving you the start amount because what they actually say in the question is, well, hold on, how much money did Hector actually start with? Okay, so in this situation, very unusually, we're going to start backwards. So what we've got here is my future value. So he's invested money. So this would have to be a positive value because again, at some point it would take the money out. So 686,904.09. So can you imagine already the number of people out there who've put negative signs in the wrong place or what have you? So 686,904.09. Right, what payment is he making? Well, it doesn't say that he's making any payments into the account, all right? For the last part here, it is compounding monthly. So I've got PPY and CPY is 12. My interest rate was 2.8%. Again, a number of people stuffed up because they put 3.2. The number of payments, well, it was 10 years at 12 payments a year. So in that situation, when I hit PV, I get minus, he says writing in highlights again, minus 519320 point, let's say 30. Now actually, although I'm writing that down, I'm not actually going to round my numbers. I always round for my very, very last number. Now this was the trick to the question. So we've gone backwards. All right, so we've done this bit here. I'm now going to focus on this here. He's made a one-off payment. So this was 10 years ago. That principal value at this moment includes his $10,000. So I've actually got to take $10,000 off of there, right? Because that is going to be the value he got before he put his $10,000 in. I'm now going to copy and paste this because I'm now saying, well, after the initial 10 years, he had 509,320,30 cents. All right. So I'm now back to this section here. All right. So I'm now back to my 10 years ago. So what interest rate has he got? He's got 3.2%. It's 10 years because he's done 10 years. It's 20 years in total. That stays as 120. He's not made any PMT and my PPY is 12. So with any luck, if I now hit enter again, I get 36999.9960 and that is my correct answer. So what it means is he opened his account with $370,000. So again, I would suggest in this situation that B was my correct answer. Now, because it's question 30 and it's the last question, what I tend to say to people doing their VCAR exam is work through the rest of the paper, slam through the paper, do what you can, and then leave the last questions in each of the section. They're going to be the time killers. They're going to be the ones that people who've got really bad technique are going to stress and stress over and spend 15 minutes doing and then run out of time towards the end of the exam. If all else failed, you could actually start with each of these values and then work it through as if it was a standard question. So start with the PV as that, and then 3.2%, wind up what your final value is, then add 10,000 and then do it that way. And if that didn't work, you'd move on to B. Time consuming, but if you've got the time at the end, you can actually do it. All right, so again, I really like this question. I mean, I didn't when I first met it from VCAR when I did the work solutions because I was like, ooh, that's not very nice. But again, it's nice now because, you know, the Cambridge textbook are giving this a bit more time. Mariska plans to retire. So just again, let's just clear this down. There's probably a menu function that can do this. And one day I'll work out what it is, but we'll go there for the moment. Right, Mariska plans to retire from work 10 years from now. Her retirement goal is to have a balance of 600,000 in an annuity investment at that time. So this value here, this 600,000 is obviously my final value. The present value of this annuity investment is, oh, hold on a moment. So we seem to have a present value, which she earns an interest rate of 3.24% per annum compounding monthly. All right. To make this investment grow faster, Mariska will add $1,000, okay, at the end of every month. 2 years from now, so there's my change of conditions. She's going to do something for 2 years and then something is going to change. Okay, 2 years from now, she expects the interest rate of this investment to fall to 3.2% per annum compounding monthly and is expected to remain at this rate until Mariska retires. When the interest rate drops, she must increase her monthly payment if she's to reach her retirement goal. And again, a lot of wording in all this. Basically, we want to end up with $600,000. Right, okay, I've got the idea of the question. Let's try and put the information into my financial solver. Her retirement goal is, so the present value, so I'm going to open up my PV, and it's 265,298.48. What is her payment? It says, hold on a moment, and that would have to be negative. The reason it's negative is because it's an annuity investment, so it's got to be a minus. She's paying in $1,000 minus 1,000. I want to work out what her future value is at the end of the 2 years, right? So we got, let me see, 2 times 12 there. My interest rate was 3.24%. And my PPY and CPY are 12. So at the end of the second year, she has, and again, I always write this down just in case I stuff up some point in the question, $307,794.50. Fabulous. Right, so 2 years from now, she expects the rate of the interest to change. So now, because I've got a future value, I'm going to copy it, I'm going to paste it back in here, and I'm going to change my sign. The reason I'm changing my sign is because I'm almost thinking this as a new question. She's gone, she's done the 2 years, she's walked into the bank, she's taken the money out, and she's reinvesting it after 2 years. So that's now going to be a negative. My interest rate is going to change to 3.2. My number of payments, well, she's paid 2 years. She wants to retire in 10, so she's still got 8 years left of those 12 months of payments. What's my future value going to be? Well, again, it says she wants to get to 600,000. Now, again, 600, 1, 2, 3. When I did this question about 20 minutes ago, I could get them the wrong answer because I missed a zero off. Common mistake. And I think that's my information in. So if I hit PMT now, I get that she's going to change her payments to $1,854. And so E in that situation would be my answer. And believe it or not, that is very much the last question for this particular section. All right, there are lots of other questions out there. And, you know, if you need to trawl through the VCAR questions and look for the last question in every section, if you can get hold of past SACs, particularly those students who I am teaching or are in the school I'm in, we publish past SACs that go back 3 or 4 years. You are very, very, very much encouraged to go and do past SACs first, then VCAR questions, then the chapter questions, because, you know, I think that's going to help you enormously. Right, I've got 2 more sections to go through. I've got interest-only loans and perpetuities, which are very much the same. So give me a moment while I load up the screen. He says, hitting the wrong one. Okie dokie, so I am back. Hi, Darren. Lovely video of you. Thank you very much, Martin. Great to see you. Now I'm really nervous because you really are the guru out there, but I'm just going to talk to myself as if I normally do, but really good to see you. Hopefully you are well. Rightio, what are we doing? Interest-only loans. Now, interest-only loans. Many, many years ago, back in the United Kingdom, some bright spark in the world said, I know what we're going to do. We're actually going to make something called an interest-only loan. People are struggling out there to own homes. So what we're going to do is we're going to let you just pay the interest. And I'm like, really, Jenny? Hi, really good to see you. Or see you or have you. Really, really greatly appreciated. Ty, would you recommend doing practice exams over notes? My maths teacher was saying that it would be better to do practice SACs. 100%. Practice SACs first, right? Because you'll get used to the type of questions that we've actually set and the structure and where the tricks are. So that's point number 1. Then I know you particularly have access to all of my notes. And so I've taken all the VCAR questions from the financial questions from something like 2018 to 2022. If you smash through those now as part of your revision, you're going to see how VCAR try and trick you. And more importantly, it's more about not just the tricks, but it's like, what don't you understand? What is it in your head that hasn't quite made sense? Okay, so Basically, yep, sacks first, slam through those and get your teacher to mark them. Do them under test conditions, do them under time conditions. Can you do them under time conditions? Do you have time to go back and check the answers? All of these things are vital learnings for any SAC, right? And those VCAR questions, I promise you, have got some really interestingly tricky ones, and it really does test your understanding. All right, so going back to my interest only problems. Basically, at this moment in time, if I look at my current mortgage and it terrifies me that I'm paying this much money, and I know that there are other people out there probably paying way more than I am, I'm paying $2,000 a month for the, just to have a home over my head. What scares me the most is of that $2,000, $1,000 of it is paid off of my loan, and $1,000 goes to the bank. Oh yes, just here, bank, have $1,000 of my hard-earned cash. Yes, I never see that dollar. So for my mortgage, which is about $350,000, I'm only paying off $1,000 a month. Can you imagine how long it's going to take me to pay that off? Yes, terrifyingly long. But some bright spark years ago went, you know what? We're just going to charge people the interest. What a great idea. So they won't need to pay $2,000. They'll just need to pay $1,000. Whoop! Think of all the people who take out mortgages now, they can own homes. The problem is, in the United Kingdom and muchly around the world, people probably didn't read the small print or didn't think about the small print, because although they had taken out $350,000 and were only paying $1,000 a month for their mortgage, they weren't paying anything off this $350,000. And so what was happening was, at the end of their 25 years, particularly when people had retired and gone, oh, the great life, now I'm going to retire, the banks turned around and said, okay, your mortgage is paid, now pay me back the $350,000. And lots of people were like, what do you mean pay you back the $350,000? I don't have $350,000. And therein lay the problem. They weren't paying back their principal value. And so guess how the bank got their $350,000? Oh yes, they made them sell their home. So people then ultimately became homeless. A terrifying idea with regards to interest-only loans, right? So if you take one of those out, just be aware you've also got to put money aside to one day pay back the bank. So the point that I'm trying to get at with all of this here, and I'm going to make myself a little bit smaller now, is, and I'm going to skip that slide for a moment, is that for interest-only loans, you do not pay back any of the principal. So for your financial solver, your principal value and your final value will always be the same. Now, the next thing I'm going to ask you to think about is, well, what would your value of N be? Because N is the number of payments, yeah? Now, normally when I take out a loan, my payments might be, I don't know, 30 years at 12 payments a year, 360 payments, or whatever it works out to be. But if I'm paying interest only, it doesn't matter how many payments I'm making, because I'm never going to clear the loan in a billion years. It doesn't matter if I pay 1 month of interest, 10 months of interest, 1,000 months of interest, the value is going to stay the same. So in that situation, what I'm trying to tell you is your value of N, generally speaking, you can be 1, it can be any value you like. Most people put 1. But these are all things linked or there to try and trick you, all right? And I always think these exams there are more about trying to trick you than test your understanding. Yes, I know. Evil VCAR. Right, so what am I saying here? The present value and the future value are the same. Oh, by the way, if you guys are out there watching, mathsguru.com, absolutely free to sign up. The notes that I'm writing on behind me can be downloaded. There are past exam questions. I go through the VCAR questions. All right, it is there for you to use, all right? And spread the word, greatly appreciated if you can. So again, you're not paying back any of the principal. And here we go. Now, I think these questions are always a bit of a trick, all right? And again, this has come from the Cambridge textbook. And for those of you who've been watching my videos all the way through will get sick to death of me talking about this, because I don't do it stage by stage by stage. I have taught you all the way through this course. If you understand this formula here, you are sorted for pretty much everything. Now, Cambridge put this one in here. Okay, whatever. I tend to think of this in a slightly different way. I think I've got it on another slide somewhere else, but I tend to think of it as, if I'm trying to find this payment of D, if I'm trying to find this value here, which is always going to be the interest, I know that I can take my interest rate, whatever's in the question, all right, and I'm going to make that my compounding interest rate. I can divide that by 100, and I can times it by my value of V0, and that will always always give you your interest payment or later on your perpetuity. And so if you think of it in a different way, life is good. And I'll show you where exams try and trick you. So Jane borrows $50,000 to buy some shares. Thankfully not Bitcoin. That would be terrifying. Who actually, Jane, lend me $50,000, right? I don't have. Moving on. Jane negotiates an interest-only loan. So obviously that's there to try and help you sort of identify which part of the maths at an interest rate of 9% per annum, compounding monthly. Now again, my thinking is whenever I see 9% per month, 9% per annum divided by 12, I always work out my little bit of interest there. So I'm going to hit escape, do 9 divided by 12, hit enter, and what do we get? I get a monthly interest rate of 0.75%. Now, the reason I work that out is because every single month she is only paying the interest. And so the interest is 0.75% of the $50,000. All right. So again, what is the monthly amount that Jane is going to be required to pay? So in which case I can do 0.75% of $50,000. Now, again, for those of you who are smashing at maths, you'll know that a percent sign is a divided by 100. An of sign is times, and 50, 1, 2, 3. And again, I've got my calculator up, so come on, 0.75 divided by 100, hit enter, times by 50, 1, 2, 3, ka-ching, and there we go, $375 per month, right? So $375. There we go. Now, obviously, I can use my financial solver, can I? Well, sometimes yes, sometimes no. Now, the trick to these questions is if they do not give you the principal value, you don't know the final value. And so if you think about it, if I don't know the principal value, I won't know that value there, and I won't know my final value, I can't use the financial solver. Why? Because you can only have one of those things be unknown. If you remember, if it's two things, ka-ching, you crash and burn. But again, that's probably then a trick to the question that you would undoubtedly have to go back to this style of working out here. So if I fire up my financial solver, and again, ClassPad users, my apologies, I don't have my ClassPad license anymore, but the functionality is pretty similar. So let's go menu, 8.1, rightio. So ignoring that information from a previous question, Jane borrows $50,000. So she's borrowing it, she's getting money, 50, 1, 2, 3. Right now, because it is an interest-only loan, my future value and my principal value are the same. So minus 50, 1, 2, 3. What is my interest rate? 9% per annum. I don't need to divide it by 12 because the CAS does it all. My payments per year and my compounds per year are 12. Why? Because the question tells me so. It's compounding monthly. What is my PMT? Well, that's what we're about to try and find out. Well, what's my value of n? They don't give me a time. No, because again, it's interest only. So in which case you can use any value of n you like. I tend to use 1. So I've got all the information in there. Now, if I am really lucky and hit enter, I love it when a plan comes together, minus 375. But as I've said before, lots of students teach, okay, well, do I have to put the minus sign in? No. The minus sign there is for context. It's the calculator needs it to help it work out all of its value. You just need to know that that's a payment, and it says here what is the amount that Jane is required to pay. So I would be putting $375. Ka-ching, the world goes crazy. A loan at 6% per annum compounding monthly requires payments of $40 each month. If the loan is an interest-only loan, what is the principal? And again, the second I saw what is the principal, I know I cannot use my financial solver. So in this situation, can he be used? Can he be used? Why? Because I don't know my principal, which means I won't know my final value, which means that my financial solver hasn't got the information. So it's got to be a trick. Okay, so again, if I look at the information the question gives me, 6% per annum, compounding monthly. Oh, okay then. So my R is going to be 6 divided by 12, which is 0.5%. So my monthly interest rate is 0.5%. They're giving me the payment. Right. So I now know that 0.5% of my principal value must be $440. Yeah, because that's my monthly interest rate for my principal value, which gives me that 440. How do I work this out? Well, two ways. One, very impressed that one of my students actually taught me something that I hadn't really thought of before. But anyway, if 0.5% of something is 440, then 1% of something would be 880. And so 100% of something would be 88000. Yep, or $88,000. Right, that's one way to do it. That's certainly not the way I thought to do it. I basically put this in a solve function where I made my principal value X, I made my percent sign divide by 100, and I put solve on there, and believe it or not, out came $88,000. So horses for courses, that was probably an easier one to do in your head, but ultimately that would have given you my right answer. An interest-only loan of $1 million requires quarterly payments. And again, oh, interesting what they did there. I get so used to monthly, my brain almost got tricked there with the quarterly payments of $4,000. What is the annual interest rate? Can I use the finance solver? Probably yes, because they've given me my initial value, all right? But again, could I work it out without? Probably. I could do it by pencil and paper. Let's see what happens if I use my TI Inspire. N, it's an interest only, can be anything. I'm trying to find my interest rate. My principal value, I've taken out a loan, 123. My future value would be minus 123. My PPY and my CPY would need to be 4. So an interest only loan, it's got quarterly payments of 4,000. So minus 4, 123. And what is the interest rate? Hit enter, and there we go. So is that my right answer? Is it 1.6%? So I'm going to write 1.6%, he says, in highlighter. I'm going to write 1.6%, and do I move on now? Well, yeah, absolutely. Because a lot of people get tricked here, and they would then have times that by 4. But if you remember, your finance solver gives you the annual interest rate. So I'm 99.86% sure that that there is going to be my correct answer. Now, if I'm right, yep, that is the end of this particular video. All right, so that was what, 8 minutes? Over to you. There are no VCAR questions for this at the moment because there weren't any that stood alone as sort of interest only, and sort of I met a little bit of that in the previous video. So I'm going to do perpetuities, and then pretty much for this live stream, which is going to be short, I'll be done. But remember, I'll be back with next week data and statistics, where I will slam through all of the stuff for data and statistics. So give me a minute, I'm just going to fire up my next slide. And I'm back. Did you miss me? Probably not. All right, perpetuities. All right. Oh, great subject, but sheesh, does it confuse people, right? It really, really shouldn't. All right. So fingers crossed. Let's see what we can come up with. What is a perpetuity? Well, basically, it's a scholarship. For those of you at school who understand the idea of a scholarship, basically, when I shuffle off this mortal coil, when I pass away, when my clogs doth get parked, the chances are I will, undoubtedly leave money to someone, hopefully my daughter, and I may well leave it in perpetuity. Now, what that means is she will ultimately just live off the interest. Hopefully one day Maths Guru will take off and I'll be a multi-millionaire. Never going to happen. But I might, for example, leave $1 million in a bank account for my daughter with very strict instructions that she is only to live off the interest. That means regardless of how long that money is in my bank account, 1 year, 10 years, 100 years, it'll always have $1 million in there. She will only live off the interest. Now, sadly, that interest might only be $20, in which case she's going to be very, very sad. But imagine if I was a school and somebody had left me, I don't know, $20 million. That would be a considerable amount of money, which in a high interest account may well give, I don't know, say $40,000 a year. Well, that there sounds like a scholarship. And a scholarship is effectively the interest on a bank account. So most schools will put a load of money in an account, earn the interest, and so long as that account doesn't ever go down, they will basically, it will go to perpetuity. I think that's the correct way to actually say that. So I'm not going to recap the lesson. Obviously, if you want to watch this online on mathsguru.com, you absolutely can, but it is there for you to help. The notes can be downloaded. So a perpetuity. Well, hold on a moment. That sounds, you just said that the principal value, or I just said the principal value and the final value stayed the same. Isn't that what we just talked about with interest-only loans? Absolutely. Perpetuities are exactly like interest-only loans. So rather than paying the bank interest, The only difference is a perpetuity pays me some money. It's paying me the interest. Subtle difference, but basically the same idea with working out. So again, as I say here, my PV and my FV stay exactly the same. Nothing more, nothing less. The value then likewise can be largely useless. It can be 1, 2, 10, 100. It doesn't really matter. Now, obviously, here again is that formula I talked about a moment ago. If you want to know the amount of the perpetuity, the payment or what have you, you take your compounding interest rate, not your annual one. You turn the annual one into your compounding one by dividing by the compounding period, divide by 100 and times by fee 0. Now, when are you going to use that? Well, obviously when they don't give you the principal value, yeah? Otherwise, you can just use your financial solver. So I'm going to do some examples, then I'm going to do some VCAR questions, and then I'm going to talk about the fact that even though I've mentioned this like 100 times, students in my room today still didn't pick up on the wording of the question that said perpetuity and the question through them. So one of my students who did a trial SAC today lost only 3 marks across the whole SAC. All right, that was pretty impressive. 2 of those marks were pretty much lost because they didn't round to 2 decimal places for finance. Don't do that. And then one of them was from not picking up on the word perpetuity and getting tricked in the question. And there are tricks in VCAR questions all the time. But anyway, let's go. Calculate how much money will need to be invested in a perpetuity account earning an interest rate of 4.8% per annum, compounding monthly, if $300 will be withdrawn every month. So again, have they given me my principal value? No. Have they given me my final value? Well, obviously not. No. They have told me it's a perpetuity. Right, so in which case, actually, I'm just going to use that formula I used earlier. So I want my compounding interest rate, percent, divided by 100, times by my principal value is going to give me whatever my payment or interest is going to be. Well, I know the interest. I know my compound. I know it's going to give me $300 every month. So that's $300. I don't know what my principal value is, so I'm going to call it X. Do I know what my compounding interest rate in percent is? Oh, I can work it out because 4.8% per annum divided by 12, because it's monthly, is going to give me 0.4%. So there is 0.4. What am I going to do? I'm going to put that in the solve function, hit comma, and X. Now, obviously in this situation, for those people who did the previous example, it says, well, can't I just make that 1%? Not easily. In this situation, it's probably going to be much, much easier to use my calculator. So menu 3.1, solve, if you will, 0.4 divided by 100 times by X. And I always put the times in. He says, I don't know what happened there, times by X equals 300, comma X. Hit enter, and out comes the correct answer of $75,123. Ka-ching. And again, you can imagine that in a SAC or in an exam, the chances are we're going to try and throw something in. Why? Because sadly, a lot of people out there just don't know how to do it. They don't practice. They think it's too hard. Well, that's why this resource is there. Pause the video, go back, have a look at it again later. It's there for you to try and help. But I can't do much more for you. The University Mathematics faculty has $30,000 to invest. My mind is already going, there is my principal value. It intends to award an annual prize. There we go. That was the trick to this question. Annual mathematics prize of $1,500. So the interest on that $30,000 is going to be $1,500 with interest earned from investing this money in a perpetuity. What is the minimum interest rate that will allow this prize to be awarded indefinitely? Right. Well, okay. We know that we've got $1,500. If I divide that by my principal value of $30,000 and times that by 100, that's going to give me my rate of interest. Remember, as we've done for amortization tables, take the payment, divide it by the previous balance, and then times it by 100. So firing out my calculator, 1,500 divided by 30,123, times it by 100, and what do we get? We get 5%. Is that my monthly interest rate or my annual interest rate? And again, we need to be very careful with these type of questions that we go back and we just check that I don't need to multiply that by anything. Number one, it would be silly to multiply that by 12 because we get an interest rate of 60%. That would be terrifying. So it would make sense that because the question said it was annual, this is an annual, that is an annual interest rate. So ka-ching there. Could I have used my finance solver to do it? Absolutely. Would you like me to? Oh, yes, please, Darren. Let me do that for you then. So N is 1. What did I want? I'm trying to find my interest rate. My principal value, it is investing. So that's minus 30, 1, 2, 3. Payment, it's going to be paying out 1,500. My final value is going to be 30, 1, 2, 3. My PPY and CPY is 1. I hope this is going to work. What is the interest rate? Hit enter. Oh, love it when a plan comes together. 5%. And again, I know that people get tricked with these questions with the minus signs and what have you. So, you know, it's probably why people find these difficult. Now, believe it or not, this is going to be the shortest live stream I've done so far. I'm probably going to be finished in about 8 minutes. So if anyone has any questions, fire them out there now because I can get to them towards the end. But here are some VCAR questions that are very representative of the type of things that trip people up, he says, including my ability to speak. Sienna invest 420,000 in a perpetuity. And again, you will not believe the number of people who skip over the word perpetuity. It's the trick to the question, which you will receive a regular monthly payment of, so again, monthly $1,890. The perpetuity earns interest at a rate of 5.4% per annum. Okay, so they've scaffolded the question. There's lots I can answer. Determine the total amount in dollars that Sienna will receive after 1 year of monthly payments. All right, so they've started the question relatively simply. They're telling me they've got $1,890 per month and they want 1 year. All right, okay, so I can put into my calculator 1890 times 12. Let's do that. Fire up my calculator, don't need that. 1890 times by 12, hit enter, gives me a grand total of dollars 22680. All right, yay. And this is what tricked people. Oh, I got very aggressive then, my apologies. Write down the value of the perpetuity. They even said it in the question, perpetuity, after Sienna has received 1 year of monthly payments. So many of the state basically went, oh, they've already had $22,680 and they, for some strange reason, took that away from the 420,000. It's a perpetuity. The whole point of a perpetuity is you never spend the principal. What you had in the start of the year, you've got in the end of the year. What you've got in the start of the year, you've got the end in 10 years. So the trick to this question was quite literally writing down 420,000. And again, a staggering number of the state got that question wrong because they just didn't get it. Sienna, this is part C. Sienna invests that 420,000. Now again, you've got to be able to cross over your skills, all right? You've literally got to cross over the skills. Why? Because they're going to ask you to write things back in recurrence relationships, right? So please realize that everything you do, even with a financial solver, can still be written as a recurrence relationship, right? Complete the recurrence relationship in terms of S0, Sn plus 1, and Sn that will model the perpetuity. Right, well, this first box here, right, fairly simple to complete, I hope, because that's the initial value. So that's 421,223. This next box, if you remember, is basically my capital R value, right? So if you remember, my capital R is 1 plus my little r on 100, right? So what do we got? We've got 4.5% per annum, and we are doing regular monthly payments. So my little value of R is 5.4 divided by 12. And again, I know the Cambridge book does it differently. I don't like the way it does it. I tend to like to always do it this way. And so again, I can fire up my calculator, put in 1 plus, what have we got here? 5.4 divided by 12. And then I'm going to divide all of that by 100, hit enter, and gives me 1.0045. And there is 0045. Now, interestingly, some years VCAR give these 2 marks. Sometimes they give them 1 mark. Sometimes they're feeling really generous because they give 1 mark if you do that correctly and 1 mark if that's correctly. But obviously this year it was just the 1 mark. So again, being able to go back and just remember all of that, you know, recurrence relation stuff, really important. Question 25, I thought, was a really clever question. It's testing your understanding, not your regurgitation. The graph below represents the value of an annuity investment in dollars. Now, a perpetuity is a type of annuity, okay? That's important. I'm sure I've said that somewhere, but if I haven't, I've just said it now. What I picked up from this question, and again, what people missed, was the fact that the value of my annuity stayed the same. But banks always pay interest. right? They will always, it might not be a lot of interest, they will pay you interest. So what was happening was our interest was being paid and then obviously withdrawn, paid, withdrawn, paid, withdrawn. So they were living off the interest. So all I needed to do with this question here was go, well, all right, so what does this recurrence relationship mean? Well, this value here, 1.015, is the interest. So if I multiply 200,000, my principal value, by the interest, and then get $2,500 more, then that will keep the value the same. And what I'm trying to say is, I'm going to do 200, 1, 2, 3, and I'm going to times it by 1.015. When I hit enter, what do I get? I get $203,000. So in this particular bank account, I would get $203,000. Well, if I minus $2,500 from that, have I ended up back at my 200,000? No. Well, then it's not a perpetuity, right? Because a perpetuity, I've got to clear that interest out and go back to where I started. So now I'm going to go to part B, 200, 1, 2, 3. I'm now going to times it by the 1.025 because my interest rate has changed. Hit enter. What happens? Oh, luckily I get 205,000. But what does the question now say? How much am I taking out of that? 5,000. And if I take the 5,000 out, I go back to the 200,000. And so that particular formula in part B is just going to go on and on and on and on for infinity and beyond. Oh, so that's a perpetuity. Well, there we go. So basically part B, or B is my correct answer. See what they're doing there. Again, it is a little bit tricky. Did you understand by looking at the graph that that was a perpetuity or that the value wasn't going up? Next one, Samuel invests 500,000 in an annuity from which he received a regular monthly payment. The balance of the annuity in dollars after n months can be modeled by a recurrence relation of this form. Okay, dokie, thank you very much. So we've hopefully got some opening amount. What have we got here? I've got some interest rate. Oh, hold on a moment, they haven't given the interest rate. Just told me it's K. Okay, minus 2,000. For what value of K would this investment act as a simple perpetuity? Ah, well, going back to that previous example, which was a really good example, this here must be the payment that's coming out my bank account. That must be the interest. Ah, well, we just go back to a problem that we had before. I now know my interest rate would be 2,000 divided by my initial investment of 500,000 times by 100. Firing up my calculator, if you will please, 2,000. I'm going to divide that by 500, 1, 2, 3. I'm going to times that by 100, and that's going to give me 0.4%. Yay! Now, hold on a moment. It wants for what value of K would this act as a simple perpetuity? Oh, okay then. Well, that's all right, because I've now got my little value of R as 0.4. I know my R is 1 plus little r on 100. So again, if I put that into my calculator, 1 plus 0.4 divided by 100 gives me 1.004. So there we go. They would be looking at that value to be 1.004. Ka-ching. Now, it seems like a lot of working out, doesn't it, for that 1 mark question, but that's how they separate out those 50s, right? The people who want the 50s are the ones who are going to do the working out. They're not going to give up. They're going to go, oh, it's 1 mark, but every single mark makes the difference between a 40 and a 30 and a 20, and unfortunately a state secret, which I really didn't know was a thing until this year, and that's just horrible. Phil invests 200,000 in an annuity from which he receives a regular monthly payment. The value of the annuity in K dollars after n months A can be modeled by the recurrence relationship. Now, obviously, I've missed the first 3 parts of the question because I'm only interested in the perpetuity section. If the payment received each month by Phil had been a different amount, right? Okay, so looking at this now, if it wasn't 3,700, the investment would act as a simple perpetuity. What monthly payment could Phil have received from this perpetuity? Well, in this situation, they've given you your rate of interest. So again, if I take my investment and multiply it by this 1.0035, so if I do 200, 1, 2, 3, and multiply it by 1.0035, there we go. I get $200,700. Well, if it's got to be a perpetuity, I've got to keep it going to that $200,000, which means I would basically have to withdraw $700. So his payment there would have to be $700. Now, I'm fairly sure that is the end of that particular video. And believe it or not, that is the end of the financial component. The world goes crazy. I did it in 45 minutes with VCAR questions and some of the change of conditions. I'm going for a lie down. Now, as I say, next week I will start the data stuff. Now, I know many of the schools out there are already working and well and truly into the data section. The initial chapters I can probably get through relatively quickly because it is all language based. And so learning the language is going to be important. Hopefully I will see you in one of those. Nobody posted any questions, so I'm assuming you're going to allow me to have an early night. This will be uploaded to YouTube and will remain free for about a week, and then it'll head over to Maths Guru, where you can, there's a new section called Crash Courses, where I'll be putting all of the crash courses on there. Ty, you are always welcome. Thank you so much. I'm sure there are many, many wonderful things you could be doing with your evening. Hopefully it has been helpful. You've got the best of both worlds. You have two pretty amazing teachers, and I'm grateful that you are following along as well. For everyone else, I'm going to call it a day. You take care, and hopefully, I'm just going to do this, see if that works. Nope, my button didn't work. I'm going to do that. That worked for Twitch. I've got a new little toy. Oh, and next week, how exciting is this? I'm getting a proper mic. I'm getting one of those proper mics. I'm not sure how I'm going to get on with it. We'll see how it goes. But if you can, spread the word, and I look forward to seeing you in another video. And again, don't forget, guys, that Maths Guru is there. It's got pretty much everything on there already, and I'm updating content all the time. Right, go.